Hello guys, in this video we'll be review chapter 1, but we'll review just few of the lessons including function and relation, function notation, domain and range, and inverse function. So what we'll be doing is that for a given relation or a function, we will identify if it's a relation or a function. We'll find the domain and range. We will find or graph the inverse of the relation or a function, and a domain and range of inverse function, and the value of the function at a given point. So the first thing is that what is a relation and a function? Relation is a description that how two variables are related or connected. And when it comes to a function is a special type of relation in which each x value is related to one and only one y value, and each relation is not a function, but every function is a relation. So my first question is, we are given a set of ordered pairs here, right? So we can name it as G, right? And we have to check whether this represents a relation or a function. Before I do that, I want to tell you that a function or a relation can be represented using a table of values, a set of ordered pairs like that. It can be a mapping diagram, it can be an equation, algebraic equation, and it can be a graph. So the first is the set of ordered pairs. So here we have to identify whether it's a function or not. So just look at the x values of each of the ordered pair, and we can see that the x value is repeating here. So it means it's not a function. It is not a function. It means the relation, right? Okay, and then we have to write the domain and range of this relation. So the domain of G will be 0, 3, 5, and the range of this relation will be 4, 5, -2, and 1. Normally it's better if you write the range or the domain in order from least to greatest. I can write -2, 1, 4, and 5. Secondly, I have to find the inverse of that relation, right? So I'll find G inverse. So for G inverse, what I will do, I will switch the coordinates. So I will write the first coordinate will become 4, 0, then 5, 3, -2, 5, and 1, 0, right? And I have to check whether this represents a relation or a function. So here if you just look at the x values of each ordered pair, it's all different, right? So it means it is a function. And the domain of this will be, domain of G inverse will be the same as the range of G. So that is -2, 1, 4, 5. And the range of G inverse will be 0, 3, 5. Okay, now what if I have to find from this given set of ordered pairs, I have to find G of 3, right? It means the value of the function at x equals 3. So just look at this ordered pair here, this ordered pair, right? So when x is 3, y is 5. So it means the answer is 5. But what if I have to find G inverse 5? So G inverse 5 so I look at the G inverse now, and look at this ordered pair, right? So here, not this ordered pair, because I'm looking at the inverse. So this is my x value, right? So I will look at this ordered pair, this one, right? So G inverse 5 is 3. Okay, so this is how we can check a given set of ordered pairs, whether it's a function or not. We can find the domain and range, and we can find the value of the function at a given point. Next, we have another a representation of function or a relation, which is called the mapping diagram. So here we can also name that as h, right? Okay, and these are my x values and these are my y values, right? So all these x values make the domain and all the y values make the range. So if I have to write the domain of h will be -4, -2, 2, and 5, and the range will be 1 and 6, right? But now if I have to check whether it represents a function, so here I can see that each x value has the different y value. It's like one x value is not related to two different y values, so it means it's a function. And if I have to find the inverse, so I will do h inverse and I will draw it again. So here that's my x and that's my y. So when we find the inverse, we switch, right? So it will be 1 and 6, and the numbers here are -4, -2, 2, and 5. And when we switch, it means 6 is related to 5, 1 is related to 2, 1 is also related to -2, and 1 also goes with -4, right? Here you can see that the x value, which is 1, that goes with many y values. So it means h inverse is not a function. Okay, and similarly for this relation or function, if I have to find h of 2, so h of 2 will be 1, right? Similarly, h of 5 equal 6. Okay, next we are given a graph and we have to check whether it's a function or not. So here when you're given a graph, you can simply check for it to be a function or not. You just draw a vertical line through the graph, right? So when you draw a vertical line through the graph, you can see that it intersects the graph at 2 points. So it means it's not a function, right? And now if I have to write the domain and range of that function, that relation, so domain will be, so I will write the domain equal, so look at the x values here. So if you just look at the x value, here the x value is your x values starts from -5 to 1. So you will write the, and so and we have all the points from -5 to 1. It means domain will be x belongs to R such that x is between -5 and 1. So x is greater than or equal to -5 and less than or equal to 1. Similarly, the range will be, you will look at the y values, right? The maximum value is 4 and the minimum value is -2. So the range will be y belongs to R such that y is greater than or equal to -2 and less than or equal to 4. Okay, next we have another graph, right? And you have to check whether it's a function or not. So here again, if you try the vertical line test, it passes through the graph at only 1 point, right? It means it is a function, right? Okay, next if I have to find the domain and range of this function, so the domain will be my x values, right? So here you can see that my graph is extending in both directions, right? To the positive x and to the negative x. So it means the domain is all real numbers. X belongs to R. But when it comes to the range, this graph has a maximum point here, maximum value. And the maximum value at that point is 3. And you can see the whole graph is below 3. So the range will be y belongs to R such that y is less than or equal to 3. Okay, next, what if I have to find the value of the function at a given point? Say if I have to find, I name this function as f of x, right? What if I have to find f of 2, right? So just when my x value is t, just look at the y value. So y value is also 2. Similarly, if I have to find f of 4, when x is 4, my y value is 0. When f is, you can say negative 4, right? So at negative 4, my y value is negative 2. So this means if you are given a graph, you can find the value of the function at a given point. Next, but if you have to graph the inverse of this function. So for that, what we do is, to find the inverse, we basically switch x and y values. So what we will do for this is we'll take some key points on the graph. So suppose I'm taking this point, I can also take another point, this and this, right? So I can name it as, this is say A, B, C. So my A is negative 2, 0. My B is 1, 3. And point C is 4, 0, right? So the corresponding point on the inverse will be, I can say it A prime, 0. This is 0, negative 2. And then I have B prime, which is 3, 1. And C prime, I can write it as 0 and 4, right? And now I graph these points on the same grid, right? So when I plot these points, so A is 0, x is 0, y is negative 2. So that's the point. B prime is when x is 3, y is 1. That's the point. When x is 0, y is 4. When x is 0, y is 4. So that's the point, right? So here when I will graph it, it will be, you can graph it like that. So that is the inverse of that function. So whenever you are ever given a graph, what you will do, you will take some key points on the graph, and then you will switch the coordinates to get the points on the inverse, and then you draw the graph. Okay, so that is, and we have done the domain and range and how to graph the inverse function, right? Okay, anything else we need to talk about on this is we did the domain and range, inverse. Okay, next we have, here you're given just a random graph, same thing. So the first thing, if you need to check whether it's a function or not, you just draw a vertical line, and the vertical line crosses the graph at one point, so it is a function. So next, if I have to write the domain of this function, right? So for domain, you just look at the x value. The graph is starting at this point, right? And it is, and here in this is going in the direction of positive x, right? So the domain will be x belongs to R, right? At this point, my x value is negative 5, right? Here is negative 5. So at negative 5, and my whole graph is on the right of negative 5. So x belongs to R such that x is greater than or equal to negative 5. And then we have to write the range. So for range, you can see that we have a maximum and the minimum y value. So the maximum value is negative 2 here, and the minimum value is negative 4, right? So the whole graph lies between negative 2 and negative 4. So y belongs to R such that y is between negative 4 and negative 2. Okay, that's the domain and range. And next, what if we have to find the value of the function at a point? Say we have to find f of, so again, just name this function as f of x, right? So, but if I have to find f of negative 3, right? So when x is negative 3, my y value is negative 2. What is f of 0? So when x is 0, the y value is negative 4. So this is how I can find the value of the function at a given point using my graph. And if I have to graph the inverse of the same function, on the same grid, I'll just say take some key points. So here I can take the key points as this one, and these 4 points. I'll write the coordinates, I will switch them, and I'll graph it again. Okay. Next we have, if you are given a function or a relation in terms of algebraic equation, right? And you have to find out whether it's a function or not. So for these type of equations, you should be able to figure out what the parent function is. So here you can see that that's a line. So the parent function is, you can write y equal x, that's a parent function, right? And a line is always a graph, right? A line is always a function, I mean. Next, we have to find the domain and range. So the domain of the linear relation is always x belongs to R, and the range is y belongs to R, right? And now, but if I have to find the value of the function at any point, say I have to find f of -2, right? So what I will do, I replace x with -2 in my function. So here I'll do 3 times -2 plus 1. So that is -6 plus 1, that is -5, right? What if I have to do 2f of 2 minus f of 0, right? So I'll do the same thing here. 2, what is f of 2? So it's better if you just find the f of 2 first. So if you do f of 2, let's do it separately. So here I can do f of 2 first. So f of 2 will be 3 times 2 plus 1, so that will be 7. And f of 0 will be 3 times 0 plus 1, which is 1. So here, to find the value of 2f of 2 minus f of 0, I plug in the value. F of 2 is 7, minus f of 0 is 1. So that is 14 minus 1, which is 13. So this is how I can find the value of a function, value of the function at a given point. Next is if I have to find the inverse of that, right? So my function is, I do here, f of x equals 3x plus 1. So the first step to find the inverse is we replace f of x with y. So y equals 3x plus 1. Then we switch the variables. So it will be x equals 3y plus 1. And then we solve for y. So we can write it as x minus 1 equals 3y. Because I have to isolate for y, I will divide both sides with 3. So I get y equals x minus 1 over 3. And finally, I will write my answer because it's an inverse function. So I will write f inverse x equals x minus 1 over 3. So this is how I can write the domain and range of a linear function. I can find the inverse of a linear function. I can identify the parent function, and I can find the value of the function at a given point. Okay, the second one here is, so first we need to find what is the parent function here, and you can see that it's a quadratic, so it means the parent function will be y equal x squared, right? Now, to find the domain and range, it's better if you just make a rough sketch here. So if you make a rough sketch, you can see that x minus 2 mean it is translated 2 units right and 1 unit down. So this is 2 units right and 1 unit down, right? And you can see that it's also it's a positive 1 here, right? It means the graph opened upward. So that's how the graph look like, right? And once you have your graph, you can always write the domain and range. So the domain will be x belongs to R, right? For quadratic, your domain is always x belongs to R. So for the range, you can see the graph has a minimum value, minimum point here. So if y belongs to R such that, and the minimum y value is -1, not 2. So, and your graph is above -2, so I'll write y belongs to R such that y is greater than or equal to -1. Okay, so this is how we can identify the domain and range, and we can that we can write the parent function. And next is, what if I have to find the value of the function at a point? Say I have to do f of 3, right? So I plug in the x as 3 in my equation. So in that equation, right? So it will be 3 minus 2 square minus 1, and that will be 1 minus 1, so that equals 0. Okay, so that is about the quadratic. Next we have another function. So you can see that this one is the parent function is the square root function, right? Y equal x. Now we have to find the domain and range of this. So what I will do is I'll make a rough sketch for that again. So here, just look at the transformation. The graph is moved 1 unit to the left. So it's 1 unit left and 3 units down. So 1 unit left and 3 down to 3, right? So that is -1 and -3. And you can also see the graph is reflected on the y-axis. Well, I mean at the x-axis, right? So it means, the parent function is like that. So if it's reflected on x-axis, the graph will be like this is the starting point, right? And the graph will be like that. Okay, and you have the coordinates of the starting point. So the domain is x belongs to R such that your whole graph is on the right of -1, so x is greater than or equal to -1. And the range is y belongs to R such that your whole graph is below -3. So y is less than or equal to -3. Okay, the next function is a reciprocal function or a rational function. So the parent function is y equals 1/x, right? And this is a function. If you graph it, you will have a vertical and the horizontal asymptote here. Okay, so if you and here if you write the restriction is x is not equal to -3. So the domain will be x belongs to R such that x is not equal to -3. Okay, and the range will be y belongs to R such that the range is, you can find the restriction from here. So y belongs to R such that y is not equal to -1. And if you have to graph this function, what you will do, you will draw your axis, right? And then there's a vertical asymptote at -3, right? So you'll draw the vertical asymptote at -3, right? So that is your vertical asymptote. And then your horizontal asymptote is at -1. So the horizontal asymptote will be at -1, right? It's like that. And you know that there is no reflection. So the graph will be like, it's here and all the way here, right? Okay, so that was about the reciprocal function. Next is a question is, for example, given the function and you have to find the value of k if f inverse -2 equals -3. Okay, so here, just look at this. You are given a point on the inverse function, right? So the point is basically -2 and -3, right? So this is a point on f inverse. So from this point, you can figure out what is the corresponding point on the function. So this means -3 and -2 is a point on f, right? Or f of x. So once you have a point on your function, what you will do, you will substitute this point in this equation and find out the k. So what you will do here is write the point -3 -2. So when you plug in into the equation, f of x equals k2 plus x. That will be f of you have to do f of -3, right? So okay, from here you can write that f of -3 equals -2. So it means this is your x and this is y. So it means when I plug in here, f of x is, f of x is y, right? So y is -2, k, and 2, and x is -3. So it means negative 2 equals k times negative 1. So it means k equals 2. So here we can use the point on the inverse and to find out the point on the original function and use that point to find the value of a constant in a given equation. So that is all about function and relation, function notation, domain and range, and inverse. So what you have learned is you can check from a given mapping diagram or a set of ordered pairs or an equation or a graph that whether it represent a function or not. You can always find the domain and range. You can graph the inverse of a function or a relation if you're given a graph of a function. Then you can find the domain and range of the inverse function, and then you can find the value of the function at a given point. Okay, thank you so much.